Hey Chill Pills, I just want to give you a real life example. I'm at work and the doctor ordered a dextrose fluid with 500 units of heparin, but the doctor ordered it in D20. But I'm not sure if we have D20 in stock. Let's go check. So I've come out to check our bin to see if we're out of the dextrose 20, and as I thought, we are out of stock, but we do have dextrose 10% 500 milliliter in stock. So I will need a bag of that. And we also have dextrose 50% in stock. These are in vials, and I will need quite a few of these, but I can utilize the dextrose 50% and our dextrose 10% to perform an alligation equation, and therefore we should be able to compound dextrose 20% when we're through. So let's look and see how to work this equation. So when it comes to pharmacy calculations, you want to start with your given information. And especially if you're studying for the pharmacy technician certification exam, you want to, and you have no clue where to start, you have no clue what formula to even input, start by writing down your given information. What has been made available to you. You can circle it within the word problem. You can underline it. You especially want to circle what question you are solving for. But definitely identify your given information. So based on the medication order that we received, we want to start with the dose ordered. That's our first information that was provided for us. And so the doctor ordered heparin 250 units and dextrose 20 500 milliliters. Next, you want to input your doses on hand. Based on the video and what I showed you, the doses we had on hand were dextrose 10% in water and dextrose 50% in water. D10 and my D50. Based on the information that we have in front of us, and it's easily to see, easily viewable, I can determine I got a higher concentration, lower concentration than what the doctor wants. It's possible I could perform an alligation equation to solve for the dextrose 20, how much I need of each of these parts, and then I could compound dextrose 20 based on what I have on hand. To do that, we'll try an alligation equation. Let's see if I can input it here. I'm going to insert a table. Yeah, that can work. And then with the table, you want to input your highest concentration in the top left corner first. So your highest concentration in the highest spot on your table. So I will input D50, and then my next lowest concentration, I'll input D10 down here, and then the concentration that you are intending on compounding, you'll put it in the middle. Now, you may notice in other videos, other images, other diagrams where instructors or teachers they may say it doesn't matter what concentration you put in what location, and it doesn't matter. You should still end up with the certain volume of parts for the second volume, for the next part, second concentration. Or let me make that more clear. It doesn't matter if you put the 10 up high or the 50 up high. You should end up with the same value for how many parts you need for your lowest concentration and how many parts you need for your highest concentration. Although I encourage you, if you are performing these equations, to stick to a standardized rule of thumb. It may not be the book standard, but stick to a standard way of performing it every single time so that you don't confuse yourself in future equations. Also, you may notice that I have a D in my values in the tables, and that D stands for the dextrose, and I like to leave my markers in my equation so I can follow along in the equation should I get confused, like where did this value come from? Well, how did you get to that? Well, if I keep my units and my markers within the equation, I can easily follow where these values came from. So right now I can easily see that the D50 came from my dose on hand and the D20 came from my dose ordered. Next, we solve for the equation. To fill out this alligation table, we'll subtract 20 from 50, and that will yield us 30 down here diagonally, and then we'll go from bottom left to top right, and we'll subtract 10 from 20, and that will yield us 10 up here. Now I have dropped my D, my moniker, my identifying marker in this last column here, but that's because I'm going to just start utilizing values and not identifying markers, because I know where these values come from at this point. So the next step is to add your parts together. We'll add 10 plus 30. Oops. And that will yield 40. I think this is going to come out real tiny. Let's see. Oh, I need it bigger. Equals 40. Next, now that we have summed the total of our parts, you can move on in two different ways. I'll show you a way I believe your textbook shows you, and then I'll show you the way that I usually work it out. I'm not sure if either way is quicker, easier, simpler, but I'll show you two ways that your brain can comprehend this, and you can solve for the remainder of the alligation equation. Now, some questions may ask you how many parts you need of each, and if it's asking how many parts, then your answer will be 10 of your dextrose, 10 parts of dextrose 50 and 30 parts of dextrose 10. Our equation, because this is a real life dose that we need to solve for, we need to know how many milliliters, because the doctor ordered 500 milliliters total. So we have to convert these parts into milliliter units. So in order to do that, now that we have the sum total of our parts, we'll then set up a proportion equation to find out how many milliliters is equivalent to 10 out of 40 parts and 30 out of 40 parts. Let me increase the size of the font here. And then set up an equation. 10, I would use the divide symbol, but I like to use the underline so you can see it clearly how the equation would set up and how the numbers align with each other. So 10 equals X Oh, it seems the software is solving for an equation that I haven't set up yet. That's kind of interesting. We'll put 40 here. Hard to control that underline. 40. Little space. And then we'll enter 500 milliliters. This is our final volume that the physician ordered. And what we're trying to solve for, if 40 is the total of all these two parts, and 40 should equal the total volume, the final volume, which is 500 milliliters, we're setting up an equation where 40 equals 500 milliliters, which it does, and 10 is the dextrose 50, 10 parts of dextrose 50. Well, how many milliliters was the equivalent of 10 parts of dextrose 50? And I keep it up here for your sake and my sake, so again, so I can easily follow along that these numbers, these values are coming from this line here. 10 parts, dextrose 50, and I'm solving for this equation. Again, how many parts? X, the unknown, is equivalent to 10 parts of dextrose 50. I usually, when I'm handwriting this, which you all will utilize when you're working with scratch paper, especially in real life, not able to utilize a calculator, or you can utilize a computer which you shouldn't need. You should be able to work these problems out with just pen and paper. And when I'm working it out with pen and paper, I would actually just draw a line right where my 10 is. I would draw a line here, and then I would draw 40 underneath, and then I would just set it equal to x over 500. So I'm not adding extra steps, an additional writing. So I'm like, wait, where did this 10 come? Where did this 40 come from? I will actually just add it right in the table. Oh, this is going to look so funny. So I already have my 30 over 40 here. I would just set this equal to x over 500. And then I would go up high, 10, draw my lines over 40, set it equal to x over 500, and then solve for both equations. But I wanted to make it clean for you all, so I'm going to get rid of that and continue. So to solve for this ratio proportion equation, I'm going to continue. I think the best way, okay, let's keep it up high. You cross multiply for ratio and proportion. If you're not familiar, you will cross multiply. You will multiply 10 times 500. That will yield 5,000. Milliliters. Ooh, that says 500. 5,000 milliliters. And then 40 multiplied by x yields 40x. And then you will divide both sides by 40 to solve for x. Then we are left with x equals 125. Okay, now we have solved for the volume that we need for our dextrose 50%. We need 125 milliliters of dextrose 50%. Now we must solve for what volume do we need for our dextrose 10%. So I set up the equation, same as I did above. 30 parts out of 40 total is the equivalent of an unknown amount of volume out of 500 milliliters. We will cross multiply our ratio and proportion equation, and that will yield 30 times 500 will yield 1,500 milliliters over 40. Oh no, we haven't solved for that yet. 1,500 milliliters is equivalent to 40 times x, which is 40x. Then we divide both sides by 40. 1,500 over 40, 40x over 40 to solve for our unknown. And that will yield 375 milliliters as our final volume for our dextrose 10%. And when we combine our 375 milliliters of dextrose 10 and our 125 milliliters of dextrose 50, that will yield 500 milliliters total, and it would also yield us a concentration of dextrose 20%. And that's how we utilize our alligation equation to compound for our concentration, our compound that's unavailable for us to utilize. And then once we compound that dextrose 20%, we'll then add 250 units of heparin into it. So that was one way to work out our alligation equation, but there's also another way that we can do to solve for our alligation table. The alligation table is set up the same, and you will solve for those values exactly the same way. So I left it here on the page so you can see that. But then I also want to work out another way that we can solve for our final volumes of dextrose 50 and dextrose 10. Rather than setting up a ratio proportion equation, we could just actually solve for the values as we go along versus setting up a ratio proportion equation and then solving for that and then solving for x. So what you would do is you take your parts, your 10 parts of dextrose 50. Go ahead and divide that by the sum total of parts of 40 and set that equal to 0.25 as your value. Then you would take that value, 0.25, multiply that by your final volume for the dose ordered, and that will yield the volume you need of dextrose 50%. That was rather simple. You will have a calculator accessible to you on a pharmacy technician certification exam, and you'll also have a calculator available to you if you're in a pharmacy setting. So you can solve for it rather quickly that way. I believe it doesn't take that long if you can do this type of multiplication in your head, or even the ratio proportion equation. You don't have to go through every step line by line, but I did that for you all so that you can see where the values were coming from, what the next step would be. I didn't want to skip any steps, so the ratio proportion equation did look like many steps, but that was only so that you could see where the values are coming from. I hate it when instructors just did the math in their head, skipped along, and then you're left wondering, well, what problem did they just solve for? Did they divide? Did they multiply? Where did it come from? So I did it step by step so that you all could see what I was doing. So we'll go ahead and do it for dextrose 10%. 30 parts out of the sum total of 40. We'll solve for that. That's 0.75. And then we'll take that value, multiply it by our total volume, and then that'll yield us 375 milliliters. And that is our, again, final volume we need for dextrose 10%. So there you have that. I'm going to go ahead. I want to highlight our answers to the equation that we were solving for. And you also want to do this when you're studying for your pharmacy tech exam. Go ahead and circle, highlight, draw a square around the answer. When you think you've solved for your answer for your calculation question, go ahead and just circle it, highlight it, draw a square around it, underline it, so you, again, okay, this is the answer. So when you're plugging it in, or when you're looking for your multiple choices, okay, this is the volumes that I'm trying to identify. Okay, so that's it. Thanks for watching my video, guys. Be sure to hit the subscribe button to check out more tips and tricks for the certification exam, and other videos I should be adding soon about how to identify drug classes by watching drug commercials, and that'll help you all study as well. See you next time.